Our logarithmic function. The definition of a logarithm. The logarithm of any number to a given base is the index of the power to which the base must be raised in order to equal the given number. What the heck? What's basically saying this? If you have a number and it's equal to a to the power of x, then the log of n base a is x. The base is the key thing here. So we say a to the power of what gives me this number. And that's basically the logarithm, is what we're talking about. N is a to the power of x. That's a mouthful. So you see something like this, and sure, you could put that one in a calculator because our calculators have base 10, but really, would you waste time? Because all we're really saying is 10 to the power of what is 1,000. 10 to the power of 3 is 1,000, so x is 3. Something like this. 5 to the power of what is 1 on 25, or 5 to the power of negative 2 is. X to the power of 2 is 64. Well, so x is 8. That must have been base 8 logarithm. 6 to the power of 2 is x. X is 36. So let's create the laws that allow us to manipulate logs. This first one here is, well, now that we've seen the basic idea of a logarithm, a to the power of x is a to the power of x. So yes, log a to the power of x base a must be x. And this one, a to the power of log x base a, is also x. Basically what we're saying is the log function and the exponential function are inverses. So if we create a composite function, they will cancel out. So if we say a to the power of log a, that will cancel. We get x. Or log a base a to the power of x will also be x. They cancel. Log of 1 of any base will equal 0. That basically is our index law. A to the power of 0 is equal to 1, just written in a different way using logs. Log a base a must equal 1, because that's just saying a to the power of 1 is equal to a. If we bring it back again to indices. Then this log law, this is the reason why that when we add logs, we multiply together, because these are actually the powers, if you like. And we have an index law that says when we multiply, we add the powers. Similar for division, that comes from that one. And then this one here, which allows us to bring the power in front of the log, well, that comes from this idea, that a to the power of x to the power of p, you would multiply the p and the x together. So what would log 20 plus log 5 be when we're talking about base 10? Because really, if we wanted to say 10 to the power of what is 20, or 10 to the power of what is 5, that's not an easy one to work out. It's not a nice, neat number. But when I combine it using my log laws, now it becomes a very simple question, because I'm saying 10 to the power of what is 100. Well, 10 squared is 100, so we get our answer. Same here. 2 to the power of what is 18, and 2 to the power of what is 9? Oh, I don't know. But if I combine them using my log laws, it's just log 2 base 2, which we know is 1. I've got 3 things added together, and again I've got the same problem. 4 to the power of what is 9, 4 to the power of what is 8, 4 to the power of what is 6, don't know. But I can recombine all these, because the adding means multiply, so I get 9 times 8. The subtraction means division, but also I've got 2 log, so I can bring the 2 in. 6 squared on the bottom, I end up with, well, 4 to the power of what is 2? Well, 4 to the power of a half would be 2. So that's a half. Okay, they've given me 2 logs to work with. Now, of course, there are approximations. I mean, 2 to the power of 0.3010 won't be exactly 2, but it'd be very close. So if I now wanted to work out 27, and the only thing I can use are these 2 logs, I then basically have to say, well, how can I get the number 27 from the numbers 3 and 2? 27 is 3 cubed. Bring the 3 out the front, substitute in what they told me that log is, and I get the answer. Square root of 2. Well, I can rewrite that as a half log 2. Substitute in what they gave me, I get the answer. Log of 12. Whoa. Again, I can only use 2 and 3, or of course I could use anything I've found in previous questions. But for this one, I'll just say, well, that's 3 times 2 squared. Substitute in the values, 1.0791 will do us. Okay.